This is section 3.2. We're going to look at quadratic equations and problem solving. These are the topics we'll be covering in this lecture. So what is a quadratic equation? Well, we already studied quadratic functions. Quadratic equations follow along the same lines. We have a, b, and c are real numbers. We assume a is not 0, then a quadratic equation is anything that can be written in the form ax squared plus bx plus c equals 0. Please note it may not be written in that form initially. So how do we go about solving quadratic equations? There's 4 basic methods that we will use. First one's factoring, second one's called the square root property, third one's completing the square, and the fourth one's the quadratic formula. Please note the third one, completing the square, is the method that I would advise not using unless you're told to use it. It's simply the longest method, and it is probably something that's a little bit more complex than most people want to use most of the time. The quadratic formula is actually completing the square already done for you, and we will talk about and discuss how both of these are applied. The factoring. Factoring is based on what's called the zero product property. It says if you multiply two things, if a times b equals 0, then either a equals 0 or b equals 0. So one of them has to be 0. When you have a quadratic equation, something like x squared minus 5x minus 14 equals 0, this factors to x minus 7 times x plus 2. Notice you're now multiplying these two binomials. So that therefore either x minus 7 is 0, so x is 7, or x plus 2 is 0, so x is negative 2. These are your two solutions. The square root property says that if k is a non-negative number, then the solutions for the following quadratic equation, x squared equals k, are simply x are plus or minus k. Notably, this is usually employed when we have a quadratic equation, ax squared plus bx plus c equals 0, when simply b equals 0. In other words, there is no x term in there. It's just the squared term and the constant c. Let's look at an example of a word problem. A ball is dropped from a building 64 feet above the street. The height of the ball from the ground is given by this function. H of t is negative 16t squared plus 64. Determine how long it takes the ball to hit the ground. The ball hits the ground when the height is 0, so we're going to plug in 0 for h of t. So negative 16t squared plus 64 is 0. We bring the negative 64 to one side. Divide both sides by negative 16, we get t squared equals 4. So if we take the square root of both sides, we get t as plus or minus 2. Now in this case, even though we have two solutions to this quadratic equation, we know we cannot have a negative time. So therefore the ball hits the ground after 2 seconds. Completing the square. This is the long drawn out process. We will go through it. You do need to get somewhat proficient with it, but again, unless you're asked to use the completing the square method, you really want to use the quadratic formula. There will be times, like we saw in the previous section, where we had to complete the square to switch from one form of a quadratic to another. The rules for completing the square were given ax squared plus bx plus c equals 0. What we're going to do is start by getting the x terms on one side of the equation by themselves. That means that we will move the c term to the other side. We need to make sure that the coefficient of x squared is 1. We need to make sure this a is 1. If it's not, we're going to divide everything by that a. Now this is the step for completing the square. We're going to take this b term, the new b term, whenever we divide by a, that term in front of the x, we're going to divide it by 2 and square the result. And what we're going to do is we're going to add that number in this step to both sides. That's the completing the square part. We're actually going to simplify both sides. Okay, the right hand side usually is the one we're going to simplify. And we're going to factor the side with the x's. And then we're going to simply apply our square root property. Let's see how this works in an example. I have 2x squared plus 10x plus 7. First step is to get the x terms on one side by themselves. So I'm going to subtract 7 from both sides. Now we need to make sure the coefficient of the x squared is 1. Well, right now the x squared is 2, so I'm going to divide everything by 2. So 2x squared becomes x squared, 10x becomes 5x, negative 7 becomes negative 7 halves. Now we're going to take the new b term, so this is my new b term, is the 5. I'm going to divide it by 2 and square it. So 5 halves squared, and I'm going to add that to both sides, 5 halves squared. So let's simplify both sides now. 5 halves squared is 25 over 4. That becomes 25 over 4 on each side. Now on the right hand side, I want to get a common denominator. I have negative 7 halves plus 25 over 4. Simply becomes negative 14 over 4 plus 25 over 4, which becomes 11 fourths. Now we want to factor the side with the x's. The reason we completed the square is because this now factors. This factors to x plus 5 halves squared. And how we got the 5 halves, that was the previous step. We took half of this b term. That is where the 5 halves come from. And whether we know this is positive or negative in here was determined by whether this b up here was positive or negative. So this factors to x plus 5 halves squared equals 11 fourths. We can now apply our square root property. We have a something squared equals a number. So we're going to square both sides, take the square root of both sides. We get x plus 5 halves equals plus or minus square root of 11 fourths. Square root of 11 fourths becomes the square root of 11 over 2. And then we're going to bring the 5 halves to the right hand side. We get x is negative 5 halves plus or minus the square root of 11 over 2. Again, this is a long process, so please get familiar with it. We do have something called the quadratic formula. Basically, it says the solution to the quadratic equation ax squared plus bx plus c equals 0, where a is not 0, is this formula here. X is negative b plus or minus the square root of b squared minus 4ac all over 2a. This is one of those things that you need to memorize and know by heart. It's one of those things you may mumble to yourself in your sleep as you're having nightmares about math. Hopefully nobody's having that bad of nightmares. But this is one of those things that you should recognize years down the road after this course has already a distant memory for you. Let's take this equation we began with. Our 2x squared plus 10x plus 7 is 0. In this case, a is 2, b is 10, and c is 7. So I'm going to plug in. My negative b becomes negative 10. Notice if I put parentheses when I plug in, plus or minus the square root of 10 squared minus 4 times 2 times 7 all over 2 times 2. This becomes negative 10 plus or minus the square root of 44 all over 4. Now I need to reduce the square root of 44. 44 is 4 times 11, and the square root of 4 is 2, so I can pull a 2 out front. I get negative 10 plus or minus 2 root 11. And notice the 10, the 2, and the 4 all have a factor of 2, so I can reduce that, and that becomes negative 5 plus or minus root 11 over 2. This was the same as in my previous problem with completing the square. It was negative 5 halves plus or minus 11 over 2, and that is definitely equivalent to negative 5 halves plus or minus 11 root 11 over 2. There's something called the discriminant when we look at quadratics. If I have a quadratic equation, ax squared plus bx plus c equals 0, the discriminant is given by d equals b squared minus 4ac. Notice this is just the stuff underneath the radical in your quadratic formula. What this does is it helps us determine things. If d is greater than 0, so if d is positive, we know there are 2 real solutions. If d is 0, there's 1 real solution. And if d is less than 0, there's no real solutions. D can also tell us how many times the graph of y equals ax squared plus bx plus c actually crosses the x-axis. Let's look at an example. Use the discriminant to determine the number of real solutions to the equation negative 8x squared plus 5x minus 9. We're going to simply use the discriminant. My a is negative 8, my b is 5, my c is negative 9. So we're going to get b squared minus 4ac is 5 squared minus 4 times negative 8 times negative 9 is negative 263. Therefore, there are simply no real solutions to this equation. Let's close out with an example. A box is being constructed by cutting a 3-inch square from the corners of a rectangular sheet of metal that is 4 inches longer than it is wide. If the box is to have a volume of 135 cubic inches, find the dimensions of the metal sheet. So the dimensions of the metal sheet will be x for the width, and we'll let x plus 4 be the length because it's 4 inches longer than it is wide. Now our volume measurement is for the box with a height of 3 inches. In other words, here's the metal sheet. I'm cutting the corners off each of the corners. I'm cutting a 3-inch square. I'm going to fold these flaps up. So as I look at the length and width of the box, it's not the length and the width of the metal sheet. Because if I cut a 3-inch corner off this corner and off this corner, then while the length may be x plus 4, I'm cutting 3 inches here and 3 inches here, cutting 6 inches off. So instead of a length of x plus 4, the length is really x minus 2, because it's x plus 4 minus 6, which is x minus 2. Similarly, the width, originally the width of the sheet was x, but I'm cutting 3 inches off here and 3 inches off here, so I'm cutting 6 inches total, so the width is x minus 6. And again, the height is the height of these flaps, which are 3 inches. So I know the height is 3 inches, the width is x minus 6, and the length is x minus 2. My volume formula is length times width times height. So 135 equals x minus 2 times x minus 6 times 3. We'll divide everything by 3 to get rid of this 3. So 45 is x minus 2 times x minus 6. Please do not try to solve here, because this only works, the zero factor problem only works if one side is equal to 0. So let's go ahead and multiply this. We get x squared minus 8x plus 12. We're going to subtract 45 from both sides. We get x squared minus 8x minus 33. So we get this factors to x minus 11 times x plus 3. So I have two answers, 11 and negative 3. And since I know I can't have a negative measurement, we know the width is 11 inches on the sheet and the length is 15 inches.